Memorizing textbook definitions for your Cambridge IGCSE computer science exam? Yeah, that is actually the fastest way to drop an entire grade boundary. Seriously. If you're just sitting there making flashcards of definitions right now, you are literally walking directly into a trap set by the examiners.
So, will memorizing definitions actually cost you marks? Yes, absolutely it will. Let's just destroy this common study myth right out of the gate. Merely memorizing the definition of a term, like, say, compression, does not guarantee you a single mark on the 0478 exam. You might think, well, I know compression reduces file size, so I'm good. But in a high-stakes exam environment, that kind of isolated fact, that's exactly where students lose out on top bands. The examiners are hunting for something entirely different.
Okay, let's look at this comparison. Look at the stark difference between a generic answer and a context-anchored answer. Over on the left, we've got a 0-mark generic label. It basically just states what compression does in a complete vacuum, like it has no connection to the real world at all. But on the right, you see a full-mark, terminology-rich answer that connects to a very specific scenario, like a school network or an embedded system. The syllabus literally dictates that topics like the aims of compression have to be understood as part of a connected structure. You're expected to use precise terminology, explain the processes clearly, compare your alternatives, and crucially link that explanation directly back to whatever scenario the question prompt actually gave you.
And you know what's really painful about this? These are classic mistakes made by learners who actually know the underlying theory, but they still lose the marks. Why? Well, because they write without any real direction. Look at these classic wrong turns. You've got vague wording, missing sequential process steps, maybe naming a device or method without actually explaining how it works, and the absolute biggest killer of all, ignoring the context. If the question asks you about data transmission for an industrial robot and your answer sounds like you're describing a generic website, boom, you drop the marks. This right here brilliantly illustrates the theoretical confusion that traps so many learners, confusing memory with storage. The theoretical foundations of computer science often depend entirely on distinguishing between nearby related concepts. If you write that compression saves memory when you actually mean secondary storage, the examiner literally stops reading. The marks disappear. Your dense revision notes have to train you to compare concepts, not just explain a single topic in total isolation.
Now, in just a moment, I'm going to show you the exact examiner clue that changes your answer completely. But first, you need the framework that makes that clue absolutely obvious. Because honestly, without the right mental map, you're just going to read right past the hints the examiner is leaving for you in the question text. Which brings us to the 4-prompt strategy.
This is the core memory structure you need to reliably tackle any reasoning question about the aims of compression, or frankly, any complex process in the 0478 syllabus. It forces your brain to snap out of that single-sentence memorization habit and build the exact paragraph structure that aligns with the mark scheme. First, what is it? Identify the exact requirement. Second, how does it work? You need to explain the process in a clear sequence that another learner could actually follow. Third, where is it used? This is your context anchor. And fourth, why is it better or worse than an alternative in that specific situation? If you can answer these 4 prompts aloud for any topic, your knowledge is actually ready for the examination.
Let's see how this works with scenario mapping. Notice how the context directly dictates your application focus. The real-world transfer here really matters. The exact same compression algorithm operates differently if the context is a school network, an industrial robot, or a smartphone. If the exam question is about a smartphone, your explanation of compression absolutely has to mention limited physical storage capacity or, mobile data bandwidth limits. If it's an industrial robot, you need to be discussing processing speed, latency, real-time transmission. Generic, one-size-fits-all responses, they rarely gain full marks. You simply have to anchor it to realistic computer science contexts.
All right, it's time to escalate the stakes a bit with an interactive challenge. Spot the error. I'm going to show you a flawed Cambridge-style student answer regarding compression, and I want you to read it and figure out exactly why it fails.
Okay, here is the quote. A student wrote, "Compression reduces the file size, so it takes up less memory on the embedded system." Look really closely at that sentence. It sounds somewhat scientific, right? Pause right now and predict why this is going to lose marks. Think about those common pitfalls and foundational mistakes we were just talking about.
And here's the examiner feedback. 0 marks. Why? Well, first off, the student confused memory with storage. Embedded systems rely on storage for file retention, not just volatile memory. Second, they completely failed to explain the process sequence.
They basically just dropped a generic label without connecting the theoretical foundation to the actual process taking place. They stated an effect, sure, but they gave absolutely zero reasoning.
Now let's rebuild that exact same answer into a top-band response. Take a look at this comparison. The flawed answer is sitting there on the left, but the improved answer on the right correctly diagnoses the demand. It uses precise terminology. It says something like, compression reduces the file size by removing redundant data, meaning the firmware requires less secondary storage space on the embedded system, allowing the device to update faster over a low-bandwidth connection. Notice the profound difference there? It anchors directly to the embedded system context. It explains the mechanism, and it gives a realistic, tangible consequence.
To make this level of detail completely automatic when you're sweating under the clock in a real exam, you need the 3-pass revision cycle.
This is the strong, layered revision strategy required to solidify this high-mark approach and achieve that real-world transfer. You can't just read your notes once and expect to magically produce top-band answers. Pass 1. Secure your definitions and your contrasts. You need to know the exact difference between memory and storage, or a compiler and an interpreter. Pass 2. Rehearse worked explanations and process diagrams. Map out the exact sequence of compression step by step. Pass 3. Build exam adaptability. This is where you mix similar terms, change the scenario from a school network to a retail database, and force yourself to justify your choices. This layered style is absolutely vital because Cambridge questions always combine theory with applied reasoning. And before you move on to the next question in your exam, run through this practical pre-submission checkpoint. Just ask yourself 4 things. Was the exact requirement identified? Is the context properly anchored? Is the process actually clear to the reader? And is an evaluation included? Like, did the question ask for causes, effects, advantages, or design decisions? Once you diagnose the demand correctly, you stop writing everything you know without direction, and you start writing exactly what the examiner actually needs to see.
Ultimately, the system replaces the myth. Replacing isolated rote memorization with this structured, context-driven framework literally eliminates dropped marks. It shifts you from just recognizing a concept to truly understanding it, and finally to flawlessly applying it. But here's the critical question you should be asking yourself right now. How do you apply this exact map in the final 7 days before your exam? You have the framework now, but if you don't structure your final week of revision correctly, the exam timing pressure will absolutely still break your focus.
That brings us to your mandatory next step to lock in your grade, the last 7 days revision map. You have the framework, but ask yourself, if you sat for the exam tomorrow, would your timing hold up, or would you fall right back into generic, 0-mark answers? You need to see exactly how to sequence these strategies right up to exam morning to ensure you don't leave a single mark on the table. Subscribe to our YouTube channel Ace the Exams, @AceTheExams_IGCSE to excel in your Cambridge examinations.